Hi everyone, welcome back to a new video. Today I will be talking about nucleophilic addition, and we will focus on the stepwise mechanism of nucleophilic addition of the cyanide ion. So first off, before starting the mechanism of the cyanide ion, let's talk about nucleophilic addition reaction. So nucleophilic addition reaction is the addition of a nucleophile when you have an aldehyde or a ketone. So a ketone, which would be two R groups, which are carbon chains, or an aldehyde, which is a carbon here and hydrogen. And this would be attacked by whether a strong nucleophile, which would be an ion, or a weak nucleophile, giving us a tetrahedral product here. The reason why in this case we are doing an addition is the transformation of a pi bond to produce two sigma bonds, in this case the hydrogen and the sigma bond of the nucleophile. The reason for that is because R and H are very bad leaving groups. They don't want to leave. So this is the reason why we have a product here that is tetrahedral. All right. So in a nucleophilic addition reaction, there's two possibilities. If you have a strong nucleophile, the first step will be the nucleophilic attack. So the nucleophile is going to attack the electron deficient carbon of the carbonyl group. An example of a strong nucleophile would be an anion or an amine. In the case where you have a weak nucleophile, the first step of the nucleophilic addition reaction is the protonation of the oxygen of the carbonyl group. In our case, for the nucleophilic addition of the cyanide ion, this is a strong nucleophile, so the first step will be the nucleophilic attack. All right, so let's start with ketone. What's the cyanide ion in the presence of an acid? So the first step, as I mentioned earlier, is the attack of the nucleophile to the electron deficient electrophile, this carbon. And while this happens, this pi bond rolls and becomes a lone pair on this oxygen, giving us this intermediate. And now is the acid is so we can protonate this oxygen here, taking the negative charge off. This gives us a cyanohydrin product. So this is a pretty simple mechanism, but it can be confusing with other type of reaction, whether it's addition, elimination, electrophilic addition. What is very important here is to locate what is your electrophile and then look at your leaving group. In this case, I was able to understand that this was a ketone, and as I mentioned earlier, this R group is a bad leaving group, so it won't leave. It will still be in the final product, which in this case gives us this tetrahedral product, which is the cyanohydrin. All right, I hope this helped, and if you guys have any questions, just leave them in the comments. Thank you.